Hi folks, how you doing? So we're just going to look at a new topic, and we're looking at circles here. There you go, a wee circle there. That's a wee line in the middle. That's the radius. Centre AB, and any point on the circumference is XY. Okay, so that's what we're dealing with here. Right. Okay. Just let's kick in with an example here. And we're just going to be using that formula there. That comes from the distance formula that we looked in straight lines. Okay, so here we get a centre of a circle here and a radius 10. So let's go and get that formula. X minus a all squared plus y minus b all squared equals r squared. A and b, that's 7 6. Okay, r is 10. Put them in, and the only thing I need to do here is square up the 100. That's it. That is it. That's the equation of this circle. That will do me for now. I've just changed it slightly, just changed the centre of the circle. Watch out, the numbers are negative, and the radius is square root of 50. Square roots are nice here. Put numbers in position. So a and b is -3, -4. R is square root of 50. Put things in position. Watch out for the negatives here. And just remember, folks, that see when you've got these negatives sitting together, they resolve themselves into pluses. Okay, so we can do that. Because we're good. We are good. We can do that. Right. So, and that's it. That is the answer. Right. Next one. Oh, centre 0 0. That's nice. 0 0. That's nice. And the radius is 1. So let's have a wee think here. Let's start sticking numbers into our formula that we've been given. X take away 0. Well, that would just be x, and it'd be squared. Y take away 0. That would be just y, and that would be squared. And 1 squared would just be 1. So there you go. This here is actually a special circle. This is actually known as the unit circle. And this is where all your sine, cos and tan come from. But nobody told you about that. But we can think about that at another time. So that's fine. So if you get that, good. Right, here's a wee exercise for you here. So all I want here is the centre and radius of each of the circles below, given the initial format that they showed you. So you can pause this wee video here and have a go at it. And I'm going to do a wee countdown here because I know you've paused it and then you've opened it back up again. So here's a countdown. 5, 4, 3, 2, 1. So I'll take my time initially in the first one. It's -2, -5. That means we just change the sign. So it's going to be 2, 5 for the centre. The radius is going to be square root of 49, which is 7. Okay, so this is how we're getting the first answer here. So I'll just get rid of that and put in the answers, because I know you've done that. So there's the first answer, 2, 5, 7. Let's think about the second one. +1, +3. We've got that there. So +1, +3. That means the centre's going to be -1, -3. And the radius is square root of 16, which is 4. Right. Oh, what about this third one here? Third one here. It's just x squared. Oh, we don't have a number next to that. If you don't have a number next to it, it's actually you're taking away 0. Okay, so we are going to have 0, positive 6 for the centre. And the square root of 25 for the centre. I hope. There you go. 0, 6 and radius 5. Okay, next one. So the centre, change the sign, so it's going to go to positive 10, and it'll be y plus 0 and the square root of 2, hopefully. Right, there you go. Bingo. Bingo. And so the first three, all the radii, that's the plural of radius, they were all nice whole numbers there, 7, 4 and 5. The last one, square root of 2, leave it as square root of 2, because sometimes you might be doing something like i.e. squaring it. So we're just going to leave it like that there. That's fine. Okay. So that was the easy part. So we're now going to look at another version of the circle equation. They call it the general equation. And there's no brackets involved here. And sometimes there is a reason for that. It makes maybe calculations easier. X squared plus y squared plus 2gx plus 2fy plus c equals 0. Right, so here, the letters, apart from x and y, we've got a g, f, and c. So the centre this time is negative g, negative f. And the radius, this is a complicated part. It's g squared plus f squared minus c. Okay, so what we're going to do here is I'll get two examples and we're going to just go and get the coordinates for the centre of each of these circles. So we're just comparing it to this here. So it's the numbers in front of x and the numbers in front of y. So we're comparing them to g and f. But what we do here is, you know, we got 2g there and we got single g there, 2f there, and negative f there. So what we're going to do is we're going to half the numbers and change the sign. That's what we are going to do here. And hopefully that's acceptable to you. So we're going to half the numbers and change the sign. Okay? Because we've got 2g in front of x, but they're saying the centre is negative g. So folks, you need to pay attention here. This is your job. So what have we got? 6x and 8y. Forget about x squared and y squared. Forget about that. It's the 6x and the 8y. That's what you're concerned about. That there and that there. So we're going to half the numbers oh, half of 6 isn't 4. Right, so that's not right. So we're going to half the numbers and change the sign. That's how we get the centre. hope. That's how we get it. Yep. Half the numbers and change the sign. There you go. Next one. Again, it's negative 10. So half of 10 is 5. It's negative, so we change it to make it a positive. And same as 16. Half 16 is 8, but change the sign, it becomes positive 8. So, I hope you're paying attention here. So, looks good. There you go. Right. Here we go. We've got another 2 here. And we're just going to go through them quite quick. Half that and change the sign. That becomes 2. Half that and change the sign. That becomes 9. The one below. Half that and change the sign. Other one. Half that and change the sign. It's positive. That should be our answers. So just get into this little routine here. You don't have to get involved in algebra. So that's all we've done there. Right. So just rewind the video and listen to what I'm saying here, and hopefully it sinks in. There you go. So it was only the x and y terms we were interested in there in order to get the centre of the circles. That's all we were interested in there. Right, let's move on. Right, this time, go and get the radius of the circle below. X squared plus y squared. Right, okay. So what I'm doing here is I'm just comparing it to the format, the new form I've given you there. X squared plus y squared. Right, so they're the same. Forget about that. You're not interested in x squared plus y squared. If it's a circle, you'll always have them. That's fine. That's okay. Right, so we're just doing a wee comparison here. Right. So it's only the 2G and the 2F we're comparing here. So I've done a wee bit of algebra there. You're good at algebra there, and it shows you the values of G, F, and C. Oh, just to let you know that C is always a number on its own. That's fine. C is 19. 19, is that a nice number? I don't know. That's fine. Right, so there's, you got G, F, and C. Okay, so there's the radius formula. G squared plus F squared take away C. Put your numbers in, and remember, especially when you get negative numbers, put them in wee brackets before you square them in your calculator, and see where that takes you. 16 plus 49, take away 19. Put that in your calculator and square root of 46. Square root of 46, is that a nice number? That 46 isn't a square number, because that lies between 36 and 49. Those two are square numbers. 36 and 49, it's close to 49. So what would that be? 6 point something. Leave it as 46. Square root of 46. Okay, just leave it. Right. Okay. And if you wanted to work out the square root of 46, go and get your calculator. If you definitely want a decimal, there you go. Have we got a calculator? So 4, 6. Can I square it? Is that a square root button? There you go. 6.78. There you go. right? That, we don't like decimals. We don't like, no. Right, but that's just in case they want a decimal answer or an approximation. You would go and do that. But we'll leave it like that. Right, let's go for the next one. Oh, here, go and get the radius of this circle below. Right, so we're looking at the 10x and the 12y. Right, so 10x, 12y. And because we're looking at radius, we need that negative 20. Because what we've got here is whatever's in front of x is 2g, and whatever is in front of y is 2f. And the number on its own, that's just c. So just looking at here, it looks like we've got g, just a wee bit of algebra. G is 5, and f is 6, and it just looks, we can just read off that c is 20. So that's sorted, okay? Remember, folks, you are experts in algebra. That's your job, to be an expert. Right, so let's go for it. I just showed you how we got G, F, and C. Put them into the form of the radius. Okay, just beware what you're doing here. Put the numbers in individually, square them, and watch out for that negative negative there. And add them all together. You get 81, which is going to get square rooted. That looks like it's going to be a nice answer. And that's 9. And just remember, when we're dealing with distances here are always positive. So that looks okay to me. So the radius here is 9, positive 9. Let's move on. Oh, taking a big breath here. Blank piece of paper means a big breath. Whew. Have a cup of tea. Right, here goes. So they're asking for the center and radius of this circle here. So there's several things going on. There's our equation, right? We don't have any brackets here. So, so what I'm waiting for first is the radius. And, oh, that's fine. So I've got that answer there. So I'm just coming back, folks. That's the radius, that's fine. I don't think I've actually put in the centre here. So I'm just going to put up here that the centre is divided as negative g, negative f. And I'm going to put it, so negative g, so there's g, there's f. So I'm going to put in, I'm just going to change the signs of those there. So if I do that, so negative g, so I'm going to go negative 3 and negative 2, so I am going to have 3 and 2. There you go. So there's my centre. and I shall just clarify that. Clarify butter. There you go. That's fine. I'm happy with that. Right. Okay. Another blank page. That means we're going to oh, we're going to go into something new. Here's where I upset you. Circle line interaction. What are they talking about here? There you got a circle. There you got a line. But we get different types of interaction here. That looks like the line is cutting the circle at two distinct points. So it looks like there's 2 points of contact. So I just want to point out here, it doesn't matter about the orientation of the line. The line could be going like that. The line would be going like that there. That's fine, because regardless of the orientation of the line, you've still got 2 points of contact. That's fine. They belong to the same family. I hope you agree with me on that. If not, please leave the room. Right, okay. So that's one scenario. Line cutting a circle at two distinct points, 2 points of contact. Next situation. 1 point of contact. That means the line is actually tangential. And just like I showed you in the last situation, it could be like that there. Could be like that there. It does not matter. It's as long as the scenario is the same. The orientation of the line is irrelevant. That line is tangential, or those last 3 lines are tangential. So that means there's 1 point of contact, without a doubt. Right. So we're talking about circle line interaction. So we've cut it at 2 points, we've cut it at 1 point. Circle line interaction. What does interaction mean? Well, interaction could actually mean you're not talking to each other. The circle's not talking to the line, which means there's no points of contact. So that technically is a mathematical interaction. Oh, don't think deeply about this. That is an interaction, believe it or not. Right, so there's 3 of them. 2 points of contact, 1 point of contact, or no points of contact. Right, okay, so where are we going from here? I think you've actually seen this scenario before. About 2 points, 1 point, no points. Where have you seen this before? The big pause is to make you think. Okay, where have you seen this before? Oh, what's that shape? That's not a circle, is it? That's meant to be a parabola. That's a very bad diagram there. Right, so we've seen this before when I looked at parabolas. So something that is parabolic, that doesn't mean that's what you get in Saturday Night. Something that's parabolic is kind of in 2 dimensions, is the graph of a quadratic function. So we've looked at them. So here, 2 points of contact, 1 point of contact, no points of contact. Where have we seen that before? Well, we've looked at that when we looked at roots of quadratic functions. 2 roots, 1 root, or no roots. And we looked at the nature of roots. And what did we look at there? Well, we looked at something, oh, that wee triangle there. B squared minus 4ac. That was a thing called the discriminant. You should remember that. It's not for me to dig it out of your memory. It's for you. The discriminant b squared minus 4ac. That lets you know about the types of roots. So, top one. What if the line intersects a parabola at 2 points? That means you've got two roots. And that tells you the value of the discriminant is actually positive or greater than 0. That's what it's saying there to you. It's greater than 0. Next one. Tangential. One root. The discriminant is actually equal to 0. And right down the bottom of the page, when the line doesn't interact with parabola, well, the discriminant was actually negative, which means it's less than 0. That's what we had there. So what we've got here is some kind of scenario with quadratics that we might be able to use circle line interaction. There's something similar going on here, folks. Something similar. So we're going to use it. You have crossover in mathematics, and maybe we can use it. Okay. So I'm going to move on here and see how we can use it. So I'm just going to come up with a question here. So we're going to have a line, and we're going to have a circle. So does this line meet the circle at all? Does it meet it in one occasion, or does it meet it on a maximum of 2 occasions? But read the question. It's only saying how many times. That's what they're saying here. They don't care about the points of contact. They just want to know, does it meet it? Not at all, on one occasion, or twice. That's all they care about. So that's how we're going to approach this question here. Right, we've got a line, we've got a circle equation. Okay. They are the important parts. So we've got our line, we've got our circle equation here. Right, there's various ways we can approach this. This is how I'm going to approach it. I'm going to take the equation of the line, and I'm going to insert it into the circle equation, because I've got y equals x minus 1 there, and I'll just show you there. I'm putting that in there because x minus 1 is equal to y. Okay, that's fine. So it's going in there. So I've removed y, and the next line I'm putting in x minus 1, so you can follow what's happening here. So x minus 1 is going to go in that bracket, but I'm still going to have a minus 1 after that. Right. Let's sort out the x minus 1 minus 1. So minus 1 minus 1 is minus 2. So we'll sort that out. Okay. So we're going to go and square up the brackets. And I've showed you this in class. Okay. For those who have actually attended class. So that there, I can sort that. I know I'm squaring the bracket, so that's really x minus 5, x minus 5. So I'll be squaring that out. And the other one, that's really x minus 2, x minus 2. So depending upon who your brilliant teacher was, they will have showed you how to deal with that. But that's just kind of, say if you're squaring a bracket with two terms, binomial, square the first, square the second. So you would get x squared, and anything negative, positive, it's going to get a positive. that'll be plus 25. And to get the middle term, multiply them together and double. Okay, so you get negative 10x. And can you do likewise with the second one? Square the first. Okay, square the first. So x squared is x squared. And square the last. So negative 2 squared is positive 4. You're going to get that. And see for the middle part, can you multiply them together? And times them 2. So x times negative 2 is negative 2x. And all that is negative 4x. So that's how we get that there. I'm going back to basically primary school with you here, showing you that. And if you don't get that, I'm shocked and horrified. So, I've just shown you that. So, and this is why I get the next line. There you go. Next line. And so I'm going to group like terms here. So what I've done here is I've got x squared, that's 2x squared, okay. I've got negative 10x, negative 4, that's negative 14x, and use a different colour pen, Tommy. 25, 4, that's 29, but I need to take away 36, because I'm going to take that over this side, so that's what I'm doing here. So I should have 2x squared, what's that, take away 14x, and yeah, I brought over that 36, and then 29 take away 36, yeah, so I've got to that point there, that's fine, that looks okay to me. Right, I'm looking at that, and I'm thinking to myself, can I factorise that? If I look at that between 5 and 10 seconds, if I look at that, and I don't have a clue, I'm thinking, I can't factorise that, so I need to use another method. But I need to remember what the question was. The question was, are there any points of contact? They're not actually asking for the specific points of contact, so I can use another method. Okay, so I've got a quadratic equation there. That's fine. So here we go. I know that's not nice to factorize. I can do it. I can do it. I can use quadratic formula. I get solutions. But they're only asking for points of contact here. Is there 2, 1, or 0? Discriminant will let you know this. So that's why I'm going down this route for the discriminant. Let's go and get the discriminant. So that means the discriminant, I've got, there you go, delta, b squared take away 4ac. So this a, b, and c, I need to know. I can read them off. Number in front of x squared is 2. Number in front of x is negative 14. Number on its own is negative 7. That's me got my ingredients for my discriminant. Let's put them in. Okay. Right. You can do this in one go or do it in parts. It's whatever suits you. However you feel is better for yourself. Right. So it looks like I'm coming up with an answer of 252. What does that 252 mean to me in terms of what I was looking at here? I was looking at this thing called the discriminant. Why was I looking at the discriminant? The discriminant We've got three things here. It's either positive, negative, or zero. That's all we're interested in. Is it positive, negative, or zero? That number 252, what is it? It's positive. That means it's greater than zero. Okay? What does that tell you? Greater than zero, positive. So do you have no roots, one root, or two roots? It's positive. It's greater than zero. So that tells you there's two distinct points of contact between the line and the circle. That's why you looked at it there. That's what we've got there. Right, okay. Let's move on. We're going to go for another one here. But do you notice in this question, they're saying determine the points of contact. They are actually asking for specific points, which means coordinates. And they wouldn't be asking you this question if there wasn't any points of contact. But there might be. But the thing is, we've got two equations. We've got our circle equation and we've got one line equation. So it's going to be probably a similar type of solution or resolution. So I think we're going to be putting that line into that circle. So that's exactly what they're saying to you. Can you put that y equals 4 take away x in the circle equation? Okay, so there we'll get rid of y because we know that y is 4 take away x. So that is going in there. We know that. That's the value of y. Put it in. Okay. Right, so you get x squared plus 4 take away x squared. Right, I'm not going to go through all the palaver of how to square up 4 take away x squared. It's done. And what I've actually done at the same time, see that 8 there? I bring that over to that side, and that's why that is negative 8. So don't be surprised. That's why you've got that there. Okay. That's the magic of algebra. Right, so we've got that there. Right, let's tidy things up. So what we've got? What can we tidy up here? Right. X squared plus x squared. That's 2x squared. We can tidy that up. And anything else? Well, we've only got one single term in x. That's negative 8x. That's fine. We've got positive 16. Take away 8. So these are the three things we're trying to resolve here. Right. Let's sort them out. And I'm sure you've got the answer. Yep. So we've got that there. 2x squared, take away 8x plus 8. That's a quadratic equation that we can solve. Let's go and solve it. Do you notice anything about the numbers here? What do you notice about the numbers? 2, negative 8, and 8. They're all divisible by 2. So 0. Why don't we do it? Why don't we divide everything by 2? You're going to end up with the same answer. We're going to end up with the same answer. Why is that? Right, I'm just going to show you here. I hate showing you stuff. Right. There's a parabola there. Parabola. Right. So, wait, I'm sorry about my rubbish. Diagram. So that's the parabola y equals 2x squared to be 8x plus 4. And it's actually got two roots. That's some highlight. So they're crossing the x-axis. And so that's kind of that one there. Okay? That's what that one there. That is different from the one downstairs. That graph is different. It's been divided by 2, and it kind of just changes the shape of the graph. It just makes it kind of shallower. Kind of like that there. So right. So that's what that's like there. The graphs are different. The shapes are different. But do you know what it's the same? Where they cross the x-axis. Why? Why? Do they cross the x-axis at the same point? Because they're equal to 0. That's what we're saying here. When we're looking at the x-axis, actually, y is equal to 0. That's what we're doing here, folks. So it's just in case nobody told you. That's what's going on here. So we're allowed to divide or multiply. We're still going to get the same roots. We're still going to get the same answers. Okay? That's why we're allowed to do that. Right. I just thought I'd let you know that. Just in case your teacher at school never told you that. But Tommy told you that. Right. So, we've got down to a quadratic equation, single x squared. That makes it easy. That means we can solve that. We can factorise that, hopefully. If you can't factorise that, use a quadratic equation. I'm not going to deal with that. Okay, so it's x squared, so it's going to be x times x. Okay, it's positive 4 at the end. That means the signs are going to be the same next to the x's. They're either going to be both positive or both negative. Look at the middle term, it's negative. They're both going to be negative. Okay, pay attention. Right, so we need two numbers that multiply to give you 4 and add up to give you 4. 2 and 2. Right, so that means separate and solve here. So x taken by 2 equals 0 or x taken by 2 equals 0. They're the same. They are the same. That means I've only got one equation here. That means x taken by 2 equals 0. So that means x equals 2. Right, that's fine. That's the one answer we've got here. That means it's really one point of contact. If you think you really need to go and look at the discriminant here. To clarify this. That's fine. Go and look at the discriminant just to clarify it for yourself. What's the discriminant? So one point of contact for the discriminant, we need a 0 answer here. So what are we going to get? So what's B? -4. What's A? That's 1. Let's see, that's 4. So if we put the numbers in here, -4 squared, what we get? 16. And 4 times A times C, I can even do that in my head because I'm clever. At 0. So if you're thinking about the discriminant, one root or 1 point of contact, so that's telling you that there, folks. Okay, that is definitely telling you that. Right. So that is why that we only get one answer, that x equals 2. Looked at the discriminant in there. That was just double checking in there. There's no harm to go through that. Right, so I've just got rid of all that stuff. Right, so let me continue. See what I've written. So there you go. So we've got the 1 point of contact that was x equals 2. See, initially we had 2 equations, the circle equation and the line equation. Put it into the simpler one. So I'm putting it into the equation of the line. That was much simpler. 4 take away x. So it's going to be 4 take away 2. Okay, that's fine. That's okay. Right. So that gives you y equals 2. So the point of contact here is 2, 2. That's it. Right. I think we're going to finish on a crescendo here, and just bear with me, folks. I'm going to go for a final one here. And if you were in my class, I did say that the initial one was kind of, in terms of algebra, that was kind of simple. Sometimes the algebra can get out of hand. So I'm just going to change things here. So we've just got a line, we've got a circle equation, and we're going to do the same thing. Okay, so it's just the algebra we need to take care of here. So 2x plus 9 into that circle equation. Let's go through the same routine. So take the line equation, 2x plus 9, and substitute it into the circle equation. So get rid of y and put in 2x plus 9. So can you see what I've done there? Again, 2x plus 9, that was a y value. That was a y value, and that's why it's going in there. Okay, everything else is stayed the same. So that means we actually eliminate y, and everything is now in terms of x. Let's tidy up the 2x plus 9, take away 5. 9 take away 5 is 4. Okay, or plus 4. So we'll get that there. Let's sort out, let's square up the brackets. X plus 2 squared. What's that? X plus 2 all squared. That's x squared plus 4x plus 4. And then 2x plus 4 all squared. What's that? I'll do that for you. Because you don't like me. So what would that would give you 4x squared. Okay, that would give you, so we're squaring the first, squaring for 4 squared, all squared is 16. And see the middle part, remember, you just multiply them together and double. So 2x times 4, what's 2x times 4? That's 8x times 2 is 16x, and everything's positive. Right, so that's why I'll be getting that there. Okay, right. Algebra is your downfall. That's why I got that. Okay. Right, I got to there. Whew. So, I need to sort things out here. I've got an x squared and a 4x squared. That's going to give me 5x squared. I've got a plus 4x and a plus 16x. That gives me plus 20x. I have got a +4 and a +16. That gives me +20. But remember, I've got an 8 there that I need to bring across. So I need to subtract that. So I need to resolve that to get -60. So I need to do all that stuff. So I'll get rid of that. So I was just showing you the arithmetic. That's all that's going on there. Just sorting out the arithmetic there. Right. Okay. So get down to there. And yes, we'll come out with up with a nice quadratic equation, and hopefully you can spot the coefficients. Coefficients means numbers in front of. They look as if they're all divisible by a similar number, and hopefully you can spot it, that they are divisible by 5. Divide them. Okay, divide them all by 5. Done. It's good. We said this earlier. When it starts with x squared, we can probably factorise it. So that's what we're going to do. We're going to go and try and factorise that. Right, okay. I'm not going to go through factorising again. That is in the factored form. So x plus 6 times x taken by 2 equals 0. Okay. So that means x plus 6 equals 0 or x taken by 2 equals 0. Let's solve them. Okay, we'll solve them. Good. X equals -6 or x equals 2. So take those two values of x because we want the points of contact. Don't lose the plot here, folks. Don't lose the plot. Points of contact, put them into the equation of the line. We could put them into the equation of a circle, but you might end up with 4 answers. And that would be true, actually. Put them into there. Equation of the line, that's the simplest form. 2x plus 9. So 2 times -6 plus 9 and 2 times 2 plus 9. So we're just going to do that there. Let's see. 2 times -6 plus 9, got an answer of -3. And 2 times 2 plus 9, get an answer of 13. That's fine. So we're just going to match them up. So with -6, it looks like we get -3 next to it. And with x equals 2, we get 13. So there are the points of contact. So I think that's us finished there. So that was quite involved there. There was a lot going on. So what I'm going to do is I'm going to finish it there. Okay, that was quite a long thing. So that's going to be 54 minutes time I hit this button. Right, bye folks.